You know that feeling when you're using an app and it just feels right? It's so smooth, so fast, it's almost like it's reading your mind. Well, today, we're going to pull back the curtain on exactly how that magic happens. We're diving deep into the invisible engine that makes it all possible. And it really all starts with this one question. Think about it for a second. What is actually going on in that tiny fraction of a second when your finger hits the screen? I'll tell you, it's a lot more than just a tap. It's the launch of an incredible journey for one single command. So let's start right there, at that very first moment. That simple touch you make is like the starting pistol at a race. It kicks off this unbelievably complex, high-speed process that's happening way down deep inside your device.
That physical touch, boom, it's instantly transformed into a digital instruction. It's a command that's about to step into this really sophisticated world inside the app. And to help us understand how these systems work, we're going to look at a conceptual model we're calling the Sunmax Bridgecode architecture.
Okay, so now we're inside. This is the world our little command has to navigate. And this isn't some chaotic, messy space. Nope, it's a highly structured, super intelligent system that's built for one thing, and one thing only: absolute speed and stability.
So, what is this Bridgecode architecture really? Well, you can see it's a 4-layer intelligent system. But here's the kicker, the thing that makes it so special. It adapts. It optimizes itself. This is not a static, dumb engine. It's more like a living system that's actually learning from how you use it. And that is why it always feels so darn responsive.
All right, let's break this down. This is the real heart of the beast. Think of it like a 4-stage rocket. First, our command hits the core processing layer. This is like the front desk. It checks the instruction in and gets it ready. Then, it's handed off to the execution matrix, which is basically a whole grid of tiny specialists ready to get the job done. From there, it taps into the adaptive memory. This part's really clever. It remembers what you do so it can start to anticipate your next move. And finally, you've got the sync pulse layer, which is like the system's heartbeat, a metronome keeping everything perfectly in time.
So, our command is processed, and it's ready for its big journey. But where's it going? Well, any app is made up of lots of different parts, or modules, and our command has to travel between them. This is where the transport network comes in. I love this analogy. The best way to picture this isn't just a bunch of data zipping around randomly. No, you have to imagine it like a super modern, high-speed railway that connects all these different digital cities inside the app. It's all about getting information exactly where it needs to be, like right now. And we're not talking about some old steam engine here. This railway is seriously advanced. It's got smart mapping that acts like a GPS, knowing exactly which city needs which piece of information. It's got priority channels. Think of them as express lanes for really urgent commands. And if a part of the track slows down, failover relays kick in and automatically reroute the traffic. You never even notice a delay.
Of course, a railway this smart needs an equally smart control tower, right? A brain that's making all the decisions. And in the world of Bridgecode, that brain is a protocol that's constantly figuring out the fastest, most efficient route for every single command.
And check this out. This is its logic cycle. It happens in a blink. First, it detects what you're trying to do. Then, it converts that into a tiny, efficient little data packet. Step 3, select. It finds the absolute fastest route on our super railway. Step 4, dispatch. It sends it flying. And finally, it waits for a little confirmation pulse to know the job is done. This whole loop happens over and over thousands of times, always getting smarter.
Okay, but what if something goes wrong? You know, a glitch in the matrix? What if there's a tiny bug or an error on the journey? Well, this is where things get really, really cool. This is where the code reveals its ability to actually heal itself in real time.
This creates this amazing contrast. On our side, what do we see? Nothing. Just pure, uninterrupted stability. No crashes, no weird slowdowns. But under the hood, it's a whole different story. The system is constantly running these little self-checks, sniffing for instructions that look off, and dynamically applying instant micro-patches to fix problems before we could ever see them. It's like an invisible guardian angel for your app experience.
So now we're at the finish line. Our little command has made its epic journey, and the result is about to pop up on our screen. This is where all that hard work pays off, creating that famous, smooth experience that feels totally instantaneous.
So, what's the secret sauce? How is it so fast?
Well, it's a special piece of the puzzle called the Rapid Flow Interaction Layer. Think of this as the VIP express lane. And get this, it's so predictive it often starts working before you've even lifted your finger off the screen.
And this isn't just some tech jargon. You feel this layer every single time you use the app. It's what powers those silky smooth UI transitions, those instant currency conversions, those charts that update in real time. It's what makes the gap between what you want and what you get feel like zero.
But to actually make it all happen, to get the work done, the system has to go even smaller. Our commands journey ends when it gets broken down into thousands of tiny, specialized, intelligent little pieces. Meet the actual workers, the boots on the ground. These are the micro-bridge instructions. They're super simple, super specific commands. Things like fetch the gold rate or switch to the dark theme. Each one is a tiny, precise action that all adds up to the big result you were looking for.
So if those are the workers, who's the boss? Who makes sure it's not total chaos? That's where the dynamic handlers come in. And the best way to think of them is like the conductor of a digital orchestra. They're prioritizing tasks, getting rid of commands we don't need anymore, and spreading the workload around so the whole system stays in perfect, beautiful balance.
So there you have it. From one single tap on a screen through a 4-layer engine across a high-speed railway all the way to a self-healing system that works in perfect harmony, it's an incredible journey. And it really makes you wonder, right? If our apps can already think and anticipate and heal themselves this fast, what on earth comes next?